Welcome guys, I have a simple question from the topic of more concept in chemistry where we are told to find the percentage purity. So percentage purity is the ratio of actual yield by theoretical yield multiplied by 100%. Now, how can we deal with a question like this one? So step number one, let's read through the question. An impure sample of sodium sulfate has a mass of 1.56. So this 1.56 is the mass of sodium sulfate, and remember we are told it's impure, so it has some impurity. So this mass of 1.56, a certain mass of it is for impurity. This sample is dissolved and allowed to react with barium chloride solution. The resulting precipitate has a mass of 2.15 grams. Calculate percentage purity. So number one, we need to come up with a balanced chemical equation. So I'm going to write sodium sulfate. This is our reactant, plus barium chloride. So this is a double displacement reaction. So sodium is more reactive than barium, so sodium will displace barium, giving us a sodium chloride. Then the barium will react with sulfate, giving us barium sulfate. So if you look at the list of insoluble salts, barium sulfate is an insoluble salt. As a result, it's a precipitate that we are looking at here. So let's convert this word equation into chemical equation. So number one, symbol for sodium is N and has a valence of 1 since it is coming from group 1. Then the sulfate is a radical SO4 with the valence of 2. So if we cross these numbers, then we are getting the chemical formula of sodium sulfate as Na2. So we have Na2SO4. Then aquat plus the barium chloride. So barium Ba is coming from group 2, so it has a valence of 2. Chlorine from group 7, it has a valence of 1. So if we cross these numbers, our chemical formula will be barium chloride 2, soluble as well. So remember, when you are trying to produce an insoluble substance, you need to make sure that the two reactants that you have used must be soluble. Now for sodium chloride, this is common, so it's NaCl aqueous. Then for barium sulfate, since barium has a valence of 2 and sulfate has a valence of 2, so the numbers are even, so this will just give us barium sulfate SO4. This will be solid S since it is a precipitate. Now upon doing this, we need to make sure that we balance our chemical equation. So let's check for sodium. So from the sodium here, we can see that we have 2 atoms of sodium from here, 2 atoms of sodium. Then here, there is just a 1. So you need to check the subscript. There is just a 1, which tells us that we need to put a 2 in front of sodium chloride. Now this 2 is affecting chlorine, which simply means that at this point we have 2 atoms of chlorine as well. Then here 2 atoms. So our equation is balanced. So now after this equation is balanced, what are we supposed to do? We are given the mass of this precipitate 2.15. So this is our theoretical yield. Now from this theoretical yield, we need to find the mass of sodium sulfate, which was pure. Remember, the 1.56 grams is from impure. So we are going to use 2.15 grams for barium sulfate because this is pure. So we can use this mass to find the mass of sodium sulfate that was pure. So we are going to use the mass to mass relationship. So let's do this. So let's find the molar mass for sodium sulfate. So from the chemical formula, we have 2 atoms of sodium. So we'll say sodium will multiply by 2 plus S times, there is a 1, plus oxygen by a 4. So the mass number for sodium is 23 times 2. Then for sulfur, 32 times 1. Oxygen, 16 times 4. So 23 times 2 is 46 plus 32 plus 16 times 4, getting 64. Then 64 plus 32 plus 46, I'm getting 142. So this 142 is the relative formula mass for sodium sulfate. Now let's find the relative formula mass for barium sulfate. So let's do that. So say Mr. for barium sulfate. So we can see that we have 1 atom of barium. So you say barium times 1 plus 1 atom of sulfate. So sulfate times 1 plus 4 atoms of oxygen. So oxygen multiplied by 4. So barium has the mass number of 137 times 1. Sulfur is 32 times 1 plus oxygen 16 by 4. So 137 by 1 is 137 plus 32 plus 64. So you can now find the sum of these three numbers: 137 plus 32 plus 64, getting 233. So 233 is for barium sulfate. So now let's use mass to mass to come up with our final answer. So what I'm going to do is now I'll say to make things simple, I'll say sodium sulfate to barium sulfate. So sodium sulfate gave us a molar mass of 142. Then barium sulfate gave us a molar mass of 233. Then here we are going to put X on the sodium sulfate since the number is not given. And for this stage, remember to consider the mole ratio. So the mole ratio for sodium sulfate is 1. The mole ratio for barium sulfate is 1. So we can just ignore since the numbers are even. Then here is where we put this mass 2.15. So the concept is simple. Find the Mr. for each compound. Then after that, use the mass of one subset to find the mass of the other. So we'll say 233 times X is 233X. Then 2.15 times 142 is 305.3 grams. So over 233 over 233. X is equal to So we'll say 2305.3 divided by 233. So I'm getting 1.31 grams. So this is the mass of the sodium sulfate that was not sodium sulfate that was pure. Remember, this 1.56 is impure. So this is now the mass that we wanted. So to find the final answer, I'll say actual yield is 1.33 divided by 1.31 divided by 2.15 times 100%, which is, if we say 1.31 divided by 2.15, then multiply by 100. So I'm getting as my final answer 60.9%. So out of 100%, 60.9% was pure. Now for question B, from this 1.56 grams of sodium sulfate that was impure, we want to find the mass of sodium sulfate. So we want to just find the purity in terms of mass. So you can just say mass of sodium sulfate. So this will be, we have the percentage purity. So remember, the percentage purity we said was 60.9. So the percentage purity multiplied by the total mass, including that mass of impurity, will give you the actual mass of that substance which was pure. So if we get 60.9 multiply by 1.56, then I'm getting 0.95 grams. So which means that from 1.56, 0.95 grams was pure, then the rest were impurity. And let's hope you know how to deal with the percentage. Maybe for someone, let me show you what we do. So to do that, the actual should be 60.9. You divide by 100. So the percentage divided by 100 multiplied by this. That's when you are going to get the actual answer, which is 0.95 grams. So that's it for this video. Thanks for watching.